So, hi everyone. I think we'll start in just 10 20 seconds. Typically, people join around this time. So, let's just wait for 10 more seconds, 10 20 seconds, and then we can start. So, I think we should start. It's already 3:05. So, good afternoon, everyone. My name is Musa Abrufi. I'm the course TA for the course Digital Circuits that is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur. I'm a PhD student in the Department of Electrical Engineering at IIT Kanpur. So every week we carry out this TA work as a part of our PMR TA duty. So this is the last live problem session, but we'll have one more live session next week at this time only. I have given my availability to the NPTEL team on this time only. So that session will be a recap session. So we'll just take a look for all problems from every week, not all problems, but some problems from all week. And if there are any doubts, we can clear in that session. So that session is scheduled on 20th October from 3 p.m. to 5 p.m. I think you'll receive an announcement and confirmation email about the same in this week only, and then you have your exams. So last week what we discussed in the week 11 live problem session was problems related to microprocessor 8085, right? This week also we'll be discussing problems related to 8085, and other than that, there's nothing to share since the roll is pretty low, attendance is pretty low today. So you can always unmute yourself after I solve a problem. You can always unmute yourself and you can ask me your doubts. So let's just start. So before we start, I'll just have a brief overview of this pin diagram of 8085. You remember in the last live session, we discussed the architecture of 8085. We just had a brief overview of the architecture of 8085, just going over all things, not going into detail because that's not the purpose of this live session. So similarly on those lines, we'll have a brief overview of pin diagram of 8085. So in 8085 there are 40 pins available. So 40 available in 8085 microprocessor. So, mu is for micro and p is for processor, and these 40 pins can be classified into 7 categories, right? Number one is your, let me just write that here. Number one, or should I move this to left and this to also left? Let's save some space. Yeah. So number one is your address bus. That is from A15 to A8. So A15 to A8, these are your address bus. It contains the most significant 8 bits of memory or input output address. Then your second is your data bus, which are your AD0 to AD7. These contain the least significant bits of your 8-bit data address and data address. The third category that we have here is control and state signal. I forgot to mark, so these are your data bus. Third is your control and status signal. They are used to identify nature of operation. Used to identify nature of operation. There are three control and three status signals. What are these three control signals? These are RD bar, write, and ALE. So this RD signal, so here are these three. So this RD signal, this signal basically indicates the selected input output or memory device which is to be read and is ready for accepting data available on the data bus. I repeat again, this signal indicates that the selected input output or memory device is to be read and is ready for accepting data available on the data bus. Then we have this write, that is WR. This signal indicates that the data can be that the data on the data bus is to be written into a selected memory or input output location. I'll repeat, this signal indicates that the data on the data bus is to be written into a selected memory or input output location. Then we have this ALE. It is a positive going pulse generated when a new operation is started by the microprocessor. So when the pulse goes high, it indicates address. When the pulse goes down, it indicates data. And apart from that, we have three status signals. These are IO/M, S1, and S0. So this IO/M, that is input output slash memory, this signal is used to differentiate between input output and memory operations. So basically, it is used to differentiate between input output and memory operations. That is when it is high, it indicates input output operation, and when it is low, it indicates a memory operation. And we have two signals, S1 and S0. These are used to identify the type of current operation, right? So in the control signals and status signals, we were having 6 pins total, 3 for control and 3 for status signals. The three control signals are RD, WR, ALE, and for three status signals, we have input output slash M, S1 and S0. Then the fourth category we have here is power supply, right? So for power supply, there are two signals or 2 pins, you can say. One is VCC and another is VSS. VCC is connected to 5 volt and VSS is connected to ground. So let me just mark these. So this is also under 3. This is completely under 3. So let's just, this is power for 4. And now coming to the fifth category we have is the clock. So the clock category will have three signals. So three clock signals. These are X1, X2, and clock out. So X1, X2 are used to set frequency of the internal clock register. Sorry. And clock out is used as a system clock for devices connected with the microprocessor. So X1, X2 are used to set frequency of the internal clock register, and clock out is used as a system clock for devices connected with the microprocessor. So these are right here. Here is clock out, it's right here. At number 6 we have interrupt and externally initiated signals. So at 6 category we have interrupts and externally initiated signals. So what are these? So interrupts are signals generated by external devices to request the microprocessor to perform a task. There are 5 interrupt signals. I think we discussed last time also. They are trap, RSC 7.5, RSC 6.5, RSC 5.5, and INTR. So what are these? So these are trap, RSC 7.5, RSC 6.5, RSC 5.5, and INTR. These are your 5 interrupt signals. Now we'll take a look at each one of them. So then also these are the 5 interrupt signals, right? Then there are also other signals like we have INTA here. It is an interrupt acknowledgement signal, means it is an interrupt acknowledgement signal. We have also reset in, ready, reset out, hold will also be there. Then hold acknowledgement will also be there, and ready signal of course is there. So this will all fall in number 6 category. So I gave a brief idea of this interrupt acknowledgement. Then there is reset in, which is here, I have shown here. This signal is used to reset the microprocessor by setting the program counter to 0 here. Then there is reset out. This signal is used to reset all the connected devices when the microprocessor is reset. Then there is ready signal. This signal indicates that the device is ready to send or receive data. If ready is low, then the CPU has to wait for ready to go high. Then we have hold. The signal indicates that another master is requesting the use of address and data bus. Then there is hold acknowledged, that is HLDA. It indicates that the CPU has received the hold request and it will relinquish the bus in the next clock cycle. HLDA is set low after the hold signal is removed. So these are some of the overview of these interrupt and external initiated signals. Now there is seventh category, that is two serial signals. So there are two serial pins. They are SOD and SID right here. So SOD is basically your serial output data line. So SOD is set reset as specified by SIM instruction, and SID is the data on this line is loaded into accumulator where RIM instructions executed. So this was just an overview of this pin diagram of 8085 microprocessor. I just given a brief overview of this. So before going to exam, just take a brief look over this. Just try to memorize the position of pins, how many pins are there, how many reset signals are there, how many interrupt signals are there. Just go over it briefly. Then we can start with the first question of today's live session. So let me just read the question first. It asks us, accumulator has data FF. Determine the state of carry flag, zero flag, and sign flag when 01 hex is added and the content of accumulator is accumulated. So two cases are given, when 1 is added to FF and when the contents of accumulator are incremented. So let's start. So we have accumulator whose contents are FF hex. So it's 1 1 1 1, then 1 1 1 1. Then we have the case first where 01 hex is added. That implies the addition operation will be like this. Uh, so 1 will be added, so it will be like this: 0 0 0 0 0 0 0 0, and 1 will be your carry. So after this we have, so after the execution of this operation, when 1 is added, my 0 flag will be 1 because all my accumulator is 0. Then my carry flag will be 1 because 1 is generated as carry, and sign flag, there is no effect of sign flag, it will be 0. Now we have case 2 where there is an increment operation on A. When we have an increment operation, one thing should be known, that the contents of incrementer are incremented by 1 However, carry flag is unaffected in increment operation. You should always remember that in the increment operation, carry flag is unaffected. It will maintain its state. So whatever was the previous state, it will be maintained. So what we'll have here is I'll have in contents of accumulator incremented by 1. So it will be like this. That implies zero flag will be 1, sign flag will be 0. And as I said, in increment operation, carry flag remains unaffected. That implies previous state is maintained. So carry previous state. So we have 0 equal to 1, carry equal to 1, sign equal to 0, and carry equal to previous state, sign equal to 0, z equal to 1, 0 flag equal to 1 for case 2. So I think it's option 2, which is your correct answer. Any doubts in here? You can ask, otherwise you can proceed to the next question. So the next question of today's live session, I would like you guys to solve first. This is basically the continuation of the previous week's problem, so it's along those lines only. So I have this question for you guys. I'll just give you a couple of minutes. I think 3 minutes should be sufficient for this question. It states that an 8080 microprocessor accesses two memory locations, 2001 hex and 2002 hex, that contain 8-bit numbers 98 hex and B1 hex. The following program is executed. So the following program is here, which is executed, and at the end of this program, the memory location 2003 contains the number in decimal. So you need to tell what number in decimal will be contained at the memory location 2003x. So I'll just wait for a couple of minutes. You can solve this question and type your answer in the chat box, and then I'll show the solution. So I hope you guys are doing it. Just wait for one more minute to type in your answers. So let me just show the solution. We have LXI H2001 hex. That means the H will be loaded with 20 and L will be 01. Then MVI will be 21 hex, so we can write it like this. Then we have increment operation on hex, so it will increase the content by 1, so it will be 2001. Now 2001 will be stored in HL pair. So earlier it was 2001, now it will be 2002. Then I have add M, so this is adding contents of accumulator to the reference data of HL pair. So HL is pointing to 2002. So 2002 contains which data? It contains B1. So that implies 21 hex will be added to B1 hex. That is equal to B is equal to B1 is equal to 10110001. So when you add it, it becomes 010001. So it becomes D2 hex. Now then we have operation INX H. So now HL will be equal to 2002 plus 1. So it will be 2003 hex. Then we have move MA. So the contents of A will be moved to the this memory location. So that is at 2003. I will be having now D2, and then I have what? That means the end of program. So after the end of the program, the 2003 will contain D2 hex. See, 2003 will contain D2 hex. So D2 hex will be present at 2003, and D2 in decimal will be 16 square, 16, 16 square, is it 16 square D2 hex? Yeah, 16 square, yeah, 16 square. No, it will not be 16 square, it will be 16 multiplied by 13 plus 16, that was 0 multiplied by 2. So it will be 16 into 3 will be 160 plus 48. 160 plus 48 is 208 plus 2, that is 210, and this is a decimal. So the answer is 210. Any doubts in this question? If not, we can move forward to this question. I hope this question you can answer very quickly. Uh, so I'll just read this question for you. I want you guys to solve it first. So which of the following 8085 microprocessor programs currently calculate the product of two 8-bit numbers stored in the registers B and C? So the idea is you have to figure out which one of the programs correctly gives you the multiplication of two 8-bit numbers stored in registers B and C. Do it. It should not take more than 1 minute. So one of the participants joined now. So we have this question where we require which one of the following programs correctly calculates the product of two 8-bit numbers stored in registers B and C. Anyone? So I'll just show you. In microprocessor, we don't have a direct multiplication, so we use addition for multiplication. So if you have two numbers A and B, how will we do multiplication? So what we'll do, we'll add A to B cumulatively. What do I mean by this? So we will add A to itself B number of times. For example, I have 2 multiplied by 3. So what I'll do, I'll add 2 3 times. This will give me the 6. So cumulative addition of 2 B number of times. 2 plus 2 plus 2, and finally I'll get the answer. So which programs here does the correct functionality of multiplication? It's C, option C. So I'll tell you how. So first accumulator contents are resetted, so it's 00 hex. Then we have the loop add C. So I have add C. Then I decrease the content of register B. Then again for non-zero case I'll go back to add C. So it will be C plus until when it goes outside the loop. So when it will go outside the loop and B will be equal to 0. So it will be C plus C plus C B times. That is your multiplication in short. So I have C, I am adding C, then I am decreasing the contents of B. I am decreasing the contents of B unless my contents become 0, I'll stop. So C will be added B times. So that is your multiplication of C cross B. Got it? Now I have question 4. Anyone like to answer? Trap is dash. Option 1 maskable highest priority and software interrupt. Option 2 non-maskable highest priority and hardware interrupt. Option 3 non-maskable hardware non-maskable highest priority software interrupt. Option 4 maskable lowest priority and hardware interrupt. Option 5 non-maskable lowest priority software interrupt. Does anyone know the answer to this question? So what there is, we have interrupts. Yeah, thank you. So we have interrupts. They are of two types. One is the hardware, the other is your software. And among hardware, you have maskable and you have non-maskable. So maskable interrupt is basically where programmer can enable disable the interrupt, and in non-maskable it cannot. And your trap, as rightly pointed out by one of the student, is your non-maskable hardware interrupt, and of course of highest priority as we saw last week as well. So that means you have option 2. So hardware interrupt is basically when a microprocessor retrieve interrupt signals through pins of microprocessor, right? So when you receive the interrupt signals of pins of microprocessor, you call them as what should I say? This hardware interrupt. Now we have question number 5 of today's live session. It states that an interrupt is in which the external device supplies its address as well as the interrupt request is dash interrupt. An interrupt in which the external device supplies its address as well as the interrupt request is dash intercept. Anyone? Yes, thank you. So it's the vectored interrupt. So basically, in vectored interrupt, in this type of interrupt, the interrupt device directs the processor or for interrupt service routine. So in this type of interrupt, the interrupt device directs the device. Interrupt device directs the process for interrupt service routine. So it's option A, vectored. In maskable, an interrupt whose interrupting service can be stopped from being served temporarily is called maskable interrupt, and non-maskable is an interrupt whose service cannot be delayed. Now, I have this question. I hope you remember the pin diagram. If not, we'll take a look at that again to solve this question. But anyways, let's check how many of you can solve it from memory. So choose an incorrect statement. Every time you read a question, just see what it's saying. It's saying an incorrect. So you have to choose the incorrect statement from the following regarding pin numbers of 8085 microprocessor. So serial input output ports are 5 and 4. Reset out clock out are 3 and 37. Ground and VCC are 20 and 40. INTR and tap are 10 and 6. Reset 6.5 and 7.5 are 7 and 8 respectively. Anyone? Which of the following is incorrect? So let's take a look at pin diagram. Let's copy it, paste it here, and let's solve our question. So we have serial input output ports are at 5 and 4 respectively. So it's correct. Reset out and clock out are 3 and 37 respectively. So it is reset out 3 and clock out 37 respectively, correct. Ground and VCC are 20 and 40. So VCC I told you is connected to plus 5 volt and VSS is connected to ground. It's also correct. INTR and trap are 10 and 6. INTR is 10, trap is 6. Their reset 6.5 is 7. No, reset 6.5 is 8. So this option is incorrect. So this is pin 8, this is pin 7. So this was the correct option. For question number 6, option 5th was the correct option. Now we can go to question number 7 of today's live session. It states that what is the length of 6 stack pointer? Anyone? Correct. It's 16 bits. So stack pointer is basically a 16-bit register that stores the address of top of the stack of memory. Stores the address of the top of stack memory, and this value of stack pointer is decremented by 2 in push and incremented by 2 in pop. Then I have question number 8. In 8085 microprocessor, which signal is used to insert weight? Anyone? In 8085 microprocessors, which signal is used to insert weight? It's option 1, ready. So Basically, this ready signal is used to delay the microprocessor read or write cycles until the slow responding peripheral is ready to send or accept data. When this signal goes low, the microprocessor waits for an integral number of clock cycles until it goes high. The hold signals HLDA and HOLD are used in DMA operations. When the hold line goes high, it indicates the processor that another master is requesting the bus access. The processor, after receiving the hold request, issues the hold acknowledgement signal on the HLDA pin. And the third one, that is address latch enable. It indicates that the bits on 87 and 80 are address bits. This signal is used to latch the lower order bits from the multiplex bus and generate a separate set of the 8 address lines A7, A0. So ready signal is used in transmit. Hold signal has two types, HLD and HOLD. When the hold line goes high, it indicates the processor that another master is requesting the bus access. So option 1, ready signal, was the correct answer. Now I have question number 10. Actually, there was supposed to be question number 9, but I checked the contents of week 12's assignment, so it was kind of overlapping. So I had to remove it at the end moment. So question number 10 is 8086 is dash bit microprocessor. I think all of us know it. It's option A, 16 bit. Then I have question number 11. It states that the trap interrupt transfers the control to location dash. So the question is, the trap interrupt transfers the control to location dash. Option A 0024, option B 002C, option C 0034, option D 003C. So the correct answer is 0024, that is option A. So when reset 5 instruction is executed, it transfers the program execution to the appropriate entry in the interrupt vector table. The vector address will be 5 multiplied by 8, that is 40. So it will be 5. So I'm this is question 11. Yeah. So basically the trap is interrupt service routine. So the answer is question option A, that is 0024 hex. Why? Because the interrupt service request address is 0024x. Discard my earlier statements that were pertaining to some other question. So the interrupt service request address is 0024x, and the correct answer to this is option A. Then I have this question which states that an 8085 assembly language program is given below. Assume that the carry flag is initially unset. The content of the accumulator after the execution of program is. So what I would like you guys is what I would like is you guys to solve it first. I think a couple of minutes will be sufficient for this question, and you can type in your answer in the chat box. After that, I'll show you the solution. I just read the question once again. An 8085 assembly language program is given below. Assume that the carry flag is initially unset. The contents of the accumulator after the execution of the program is. So you need to find out the contents of the accumulator after the following program is executed. Anyone? Has anyone done it? So I guess you guys are still solving it, or so. Let me just show you the solution. So we have this first instruction: move immediate A. So A gets loaded by 07 hex, that is 00000111, right? Then I have RLC, that is rotate accumulator left. So every bit will be shifted to left position by one bit. So it will be 00001110. Then I have move B comma A, that is contents of A will be moved to B. So B will now be 00001110, right? So this will be E, 0 E hex. Then I have again RLC, so contents of accumulator will be again shifted by one bit towards the left, so it will be 00011100. Then I have again RLC, so it will be 00111000, and then I have add B, so the accumulator contents, that is 00, this one 1000 will be added to B, which is this one 00001110. I have add operation, that is 01100010. So 01000110, so that is 46x. And finally I have RRC, so one bit shift operation will be happening towards the right, so it is 00100011, so it is 23x. So after the execution of the following set of program, I have my contents of accumulator as 23x, and that is option 3. Now I have this question which states that the contents of accumulator after the execution of the following instructions will be. So I have move immediate A. So I'll just read the question once again. The contents of accumulator after the execution of following instructions will be. So the program is MVIA B7 hex ORA RAL. So I have move immediate A B7 hex, that is A will be loaded with B 101, B will be equal to 1117 is 011. Then I have ORA, that is basically OR operation with the accumulator. So ORA, so it's basically A OR with A. When A is ORed with A, you have A, so the result will be simply A. Then I have RAL. So I have the rotate operation through left, but RAL means it will go through carry, and we'll assume carry flag is 0. So I have left shifting like this by shifting bit position towards left, and here I have carry. Basically, it is A7, A6, A5, so on up to A0. Here it's carry flag. So every bit position will be shifted to left by 1. This will go here and this will go here. So it will be 0, 0, 1, 1, 0, 1, 1, 1, 0. So this is 6. This is 8 plus 4 is 12. 12 plus 2 is 14. So it is E. This is 6E. So the answer is 6E hex. Any doubts in this question? Please let me know. So this was question number 13, right? Yeah, so answer was, let me just write the answer. 6E. Now I have question 14. I would like you guys to solve first and tell me the answer in the chat box. So find the content of accumulator. So it should be contents. Find the contents of the accumulator after the execution of the following program. So you have the following set of program and you need to find out the contents of accumulator after the following set is executed. When you are done with your question, you can write your answers. So I have one student with the answer. Thank you. It's the correct answer. So we have this MVI A, that is move immediate A, F0 X. So the contents of accumulator will be F is your 1, 1, 1, 1, 0 simply 0. Then I have OR immediate. So OR stands for OR immediate. FFX. So it's 1, 1, 1, 1, 1, 1, 1, 1, or with contents of accumulator, that is 1, 1, 1, 0. So when you do the OR operation, it is 1, 1, 1, 1, right? Now I have XRI, so this is XOR immediate. So I have XOR F0, which is 1, 1, 1, 0, 0, 0, 0. It's XOR with contents of accumulator, that is 1, 1, 1, 1, 1, 1, 1, 1. And you, when you do the bitwise XOR, it's 1, 1, 1, 1, 0, 0, 0. So it is 0. This is F. So the answer will be 0FX. That is option 3, as rightly done by one of the students. Now I have a question. I think we discussed this one. Can anyone tell me the stack pointer always points to? Yeah, the stack pointer the stack pointer always points to top of the stack. Then question 16. What happens when the below instruction encountered by 8085 microprocessor CNC 4001 hex? What happens when the following instruction is encountered by the 8085 microprocessor? Anyone? 8085 microprocessor. 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 8085 micropr So basically, call the subroutine located at 4001 hex if carry flag is not set. Then question number 17. Which of the following instructions control the interrupt enable flip flop? Which of the following uh, Question 17. Which of the following instructions control the interrupt enable flip flop? Option A trap, option B EI, option C halt, option C, yeah, EI. Correct. So basically there are two signals that can control the interrupt enable flip flop. These are EI and DI. EI and DI. Then I have question number 18. Which of the following instructions is equivalent to call 0028 hex? So the instruction that is equivalent to call 0028 hex is RST5. So when RST5 instruction is executed, it transfers the program execution to the appropriate entry in the input vector table. The vector address will be vector address. Just give me a second. Give me a second. So the vector address will be 5 multiplied by 8. So that is 40. And when you this 40 in what should I say hex, it will be 28. So the instruction is similar to call 0028 hex. So basically when a reset 5 instruction is executed, it transfers the program execution to the appropriate entry in the input vector table. So call 002xx will be similar to RST5. Now question 19. How many T states are required by 8085 microprocessor to execute CNC instruction? Option 90. Question 19. How many T states are required by the 8085 microprocessor to execute CNC instruction? So the correct answer is option D, 18. So another question. How long must INTR interrupt remain high to be sensed by 8085 microprocessor? How long must an interrupt signal remain high to be sensed by 8085 microprocessor? Question 20. So correct answer is option D, 17.5 states. Now question number C. Which of the following is not a valid 8085 instruction? Pop, PSW, Pop B, Pop C, Pop D. Anyone? So among the following options, the incorrect instruction is Pop C. Basically, Pop instruction copies the contents of two memory locations to register pair. So when you do Pop it B, it will automatically take Pop B and C. So Pop C is not a valid instruction. So which of the following is not a valid 8085 instruction? Option C, Pop C. Then another question, which group of instructions does not affect the flags? Which group of instruction does not affect the flags? A. Arithmetic operations. B. Logical operations. C. Data transfer operations. Option D. None of the above. Anyone? Yes. Data transfer operation doesn't affect any flags. Okay. What is the size of instruction queue present in 8085 microprocessor? What is the size of queue present in 8086 microprocessor? So the correct answer is option B, 6 bytes. A group of first in first out in which up to 6 byte instruction code are prefetched from the memory ahead of time. Now, question number 24. In 8086 microprocessor, which of the following registers can be combined together to use an accumulator register? Option A, AL and AH. Option B, BL and BH. Option C, CL and CH. Option D, DL and DH. So in 8086 microprocessor, it's option A, AL and AH can be combined to use a accumulator register. Now the last question of today's live session. Which of the following is performed by execution unit in 8086? Which of the following is performed by execution unit in 8086? Anyone? Yes, correct answer. Basically, EU, that's execution unit, executes the instruction already fetched by bus interface unit. So this was all of today's live session. I'll just go briefly since we have still have some time. I'll just briefly go over all the problems, and if there are any doubts, I'll just briefly go over to a couple of problems at the start of the live session that we did. So at the start of the live session, we had a brief overview of the pin diagrams. So we saw there that there are 40 pins in 8085 microprocessor, which are classified into 7 categories. So these 7 categories are, I won't dive into details right now. So these 7 categories are your address bus, which are from your A15 to A8, then your data bus. So these are your address bus, then your data bus AD0 to AD7 located here, then there is control and status signals. Basically, there are 6 pins for that. Three they are used to identify nature of operation. Three are used for control. Three are used for status. Three control signals are RD, WRALE. So they are here, and three status signals are IO/M, S1 and S0. So they are here. Then we have 2 pins for power supply. So are VCC and VDD. VCC is connected to plus 5 volt. VDD is connected. VCC connected to plus 5 volt, and VSS is connected to ground. Then we have fifth category, that is clock. Three clock signals are there, X1, X2 located here, and there is clock out located here. Then we have interrupt signals and externally initiated signals, which are located here, 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 here also. And then we have two serial signals, SOD and SID, right here. Then there was this first question which asked us to determine the state of carry flag, sign flag, and Z flag. So the contents of accumulator were FFX, and there were two cases given when 01 was added to it and when the contents of accumulator was incremented. So when 01 is added, 111 becomes the contents of accumulator becomes 0000, and 1 is generated as carry. So 0 flag will be 1 because all the bits in accumulator are 0. Carry flag is 1 because carry is generated, and sign flag is 0. However, when we do the increment operation, that is the case 2, sign carry flag remains unaffected by the increment operation. So after increment operation, my contents of accumulator was 00000. So 0 flag is 1, sign flag is 0, and carry is unaffected and it will maintain its previous state. So option B was the correct answer. Then we had this question number 2, where the following program was executed and we were to determine the contents available at location 2003 hex, and we had to write the answer in decimal. So after the following set of instructions, 210 was the required answer. Then we had this question where we required to find the correct program for the multiplication operation between two 8-bit numbers stored in register B and C. And we saw that because we don't have direct multiplication operation in microprocessor, so we use addition operation. So basically how we do is you add a number cumulatively. Basically if you have a multiplication between B and C, you will add B C number of times. So like you have 2 multiplied by 3, you will add 2 3 number of times to itself. So 2 plus 2 plus 2. So that is 2 plus 2 plus 2, that is 6. Similarly, we have this code which gives the multiplication operation of two numbers stored in registers B and C. So first the accumulator is reset, then add C is done with the loop at the loop position. Then we decrease the contents of B. So the contents of the unless the contents of register B becomes 0, we will add C to itself, and ultimately what we'll have is like this: C will be added B number of times, which is simply a multiplication operation. Then we have these simple type of questions, and then we have the question based on the pin diagram. we were required to find the correct incorrect statement. Again, this simple questions here. Then we again have the question number 12, which was based on the assembly language program was given, and we were required to find out the contents of the accumulator after the execution. And similarly, this. So rest of the questions were pretty simple, straightforward. So if there are any doubts, please let me know. And this was the last live session of this course. We will hopefully meet next week on Sunday from 3 p.m. to 5 p.m. We'll have a recap session, right? We are going to have a recap session where we'll discuss few problems from the previous live sessions. I think since we have 12 weeks, I'll take around 25, 26 problems from the previous week and discuss those problems. And if there are any other doubts, we'll discuss them also. But for today's live session and for the course, this was the last live session. So I thank you all for joining these live sessions. And this may be the last time I'm doing this TA duty. I don't know. Maybe next time I won't be available for the TA shift. Anyways, that's secondary. I'm thankful for you guys to joining in and being part of this live session. So if there are any doubts not related to the course, any other doubts, you are always welcome to ask. So any doubts pertaining to your studies, pertaining to anything else, you can ask. Otherwise, there are no doubts, no queries. We can close the live session. I wish you all the best for your exams if you are appearing in the exams. I wish you all the best for your future endeavors. And that's all. Thank you so much.